So today I will talk to you about electric field and how work and potential energy has its place in there in electric field, how all this work. At some point I ask you to review work and energy, potential and kinetic energy, and as you remember, potential energy is the energy that is stored in the object at some mass and some height. So when we hold a ball above our head, this ball has a potential energy. But if the ball will be sitting nicely on the floor, its potential energy is zero. Kinetic energy is energy of an object that it's moving, so it's energy of the moving object. So an object it's not moving at all, there is no kinetic energy. Okay, so we're gonna focus on potential energy. So you have to remember that potential energy is an object at some kind of height above the ground zero, whatever we take for the level zero. It could be a table, it could be a ground or earth or whatever we decided. Let's quick review about the directions of electric field. So we know when we have a positive charge, the electric field will go away, field lines will go away from the charge, and then if we have negative charge, the lines of electric field will go towards the charge. Okay, right here. Okay, so since we have usually the positive test charge, if we put a positive charge in here, it will repel. That's why we have the arrows going from the positive charge. And if we're gonna put this positive charge, positive test charge right here, since this will be positive in here, this is negative, they will attract each other, so we'll go towards the electric charge. Next, we will talk about gravitational field and how this is connected to our electric field. Both of those fields, gravitational and electric one, involve action at a distance force. That's pretty much the short definition of this gravitational and electric fields. So let's watch two cases. We have a stone right here, some distance above the ground, okay? And since we have the stone above the ground, pretty high, potential energy of the stone, it's pretty high. Because we know as higher the object is, then higher potential energy we'll have. So what's going to happen here, since we have gravitational force, and we all pretty much know it because we have it on Earth, gravity, right? The work done by gravity will bring this stone down closer and closer to Earth till it hits the ground. So we have a work done by gravity, right? Okay, so as the object will get closer and closer to the ground, the potential energy will get smaller and smaller. So right here, oh my goodness, sorry, very near to the ground, the potential energy, my pen stopped working, it's low, okay? So we know as object goes from higher distance to the lower distance from the ground, the potential energy will also go down, okay? The other case what we will talk about right here it's a little bit different. It's other way around. We have a stone right here that is right off the ground, and we will have, of course, low potential energy right here. And in order to bring it up, right, we're gonna kind of have to work against the nature, right? Because normally nature will bring the stone down to the ground, but to be able to raise the stone up higher, we need to raise against nature, and we all know it. If we're bringing something up, we need to apply work, and we have to apply work right here by some external forces. So after we apply the work and bring the stone up here, the potential energy will be high right here. So in both cases, what we have similar in here, we have that the stone, which that's from the definition of potential energy, higher above the ground, has a high potential energy in both cases, and right on the bottom here, very close to the earth, the potential energy is low in both cases. The only difference is that right here, when the stone is falling down, it goes from high potential energy, let me write, high potential energy to low potential energy, and it's kind of the work is done by the gravity, so it's kind of like a nature. So if there is no work required from external force, the potential energy will decrease. And in this case, we will go from low potential energy to high potential energy, and we need to use work with that. Okay, so every single time there is work applied by external force, if we apply the work, the kind of work change into the energy of the object, right? So we go in that case from lower potential energy to higher potential energy. So let's look at the cases with our electric field. So we're gonna apply kind of the same way of thinking from the gravitational force to our electric force. So let's look at the positive charge right here, and we know that the positive charge, the lines of the electric field are going away from the charge, and we are having point B right here. We have a smaller charge right here. Oh, let me make it smaller than that. Smaller charge right here, and it's a positive charge. It's a test charge, right? And we're gonna name it A. And in this case, we want this to go from point A. I will make it that. From point A to point B. So first step, what we're gonna do? We're gonna look at this, and we notice that we have two positive charges, and you already should know that they will push from each other, right? They will repel. So what we're gonna do, we kind of want to go against the nature, right? And remember, when we were going against the nature, work was required. So what we're gonna do, we need to use work. And when the work is required, what happened? Our potential energy increases. So what does it mean? If our potential energy will increase as we go towards this big positive charge in this electric field, that means that right here, this charge had low potential energy, and as it goes in here, the potential energy will increase. Every single time we need to apply work, because the movements of the charge, it's kind of going against nature. The potential energy will increase. So remember, as we pretty much this, every single time we apply work, potential energy will increase. Next example, we're going to do very similar. You have positive charge. The field is going away from our charge. And then we are having smaller charge B, positive test charge B. It's this right here. And we have a point A in here. And what we need to do, we want put this charge from here, from port B to point A. So they both positive like before. So what they're gonna do, they're gonna repel. It's that kind of working against the nature, or that will be actually this will happen due to the nature. Yes, this will happen due to the nature. So work is not required. We do not need work. Work is not required. And what will happen, we will go from a higher potential energy, from higher potential energy to lower potential energy. So we have low potential energy right here. Okay? So work is not required. This is kind of a nature, and as the object will be going on its own, it's going to be losing potential energy. The same like a stone falling down will lose potential energy. The same right here. Every single time the work is not required, we're going from high potential energy to low potential energy. So high energy location for the positive test charge is location closest to positive source of the charge, and low location is far away. So every single time we have the charge right here close to positive charge, that's high potential energy, and as far as we go, we're gonna have lower potential energy. It sounds confusing, but if you break this into the pieces, which I'm trying to do it for you, I know it's maybe still confused. It's not that hard. So if you have any questions at any point, please let me know and I will try to explain you further. Okay, so what we're gonna do now, we are going to move and look what happened and how this thing looks like with the negative charge, right? So we know we have negative charge. The lines are going towards our charge here, the electric field lines. Okay, and we have a very similar situation here. We have point B and we have test charge, positive test charge from point A, and we want to move this from point A to point B. Okay, so we go in this direction. So first step is to see what it will happen in the nature, right? So what will happen in the nature, there are two different charges, so they will attract each other, right? So from the nature, this should go right here. If this goes on its own, due to the nature, we do not need work, right? We do not need work. So if we do not need work, we kind of going from high potential energy to lower potential energy in this case. Okay, so next and very last example, we are going to look at negative charge, and the negative charge field, it's facing towards the negative charge, and we have situation here that we have positive test charge right here at point B, and we have point A. And what we're gonna do, we want to move this from point B to point A. So we're looking at both of these charges here. We have B, positive and negative, and what's gonna happen due to the nature, and we know that they both attract each other. This B, we kind of want to go this direction, but we don't want him to go this direction. We want to go against the electric field. We want to go against. When we want to get against some nature, we need to apply some work. So we have work right here. And then as we applying the work, we going from low potential energy to high potential energy. We're gonna gain potential energy as we applying work. Okay, here we go. Every single time we apply work, the kind of work that it's done by the external force, it's changing to potential energy, and that's how potential energy increases. So low energy location for positive test charge is near the negative source charge, and so here will be the low potential energy, and as we go farther from it, it will be a high potential energy. Okay, so as we're moving away from the charge, the potential will increase as because we need to move away from negative charge. We always need to apply work, right? And as we applying work and farther we go away, then potential energy will increase. Okay,